Alright, y'all, one more type of function we're going to look at today, and can you guess what this one is? Well, we already done linear, we already done quadratic, we already done absolute value, and this obviously isn't any of those. Therefore, it must be the other one, exponential, which you can see the x is up in the exponent. Other than that, nothing else is happening other than adding a 2. And adding a 2 is a arithmetic operation, which means that it's going to keep its general form of an exponential. Alright, so we're going to do the same thing that we did with all these others, and we're just going to put some numbers in, okay? So we're going to put in negative 2 for x. And so I'm going to go 2 to the negative 2 plus 2. And we know that 2 to the negative 2 is 1 over 2 squared. And 1 over 2 squared is 1 over 4. So I go 2 plus 1 over 4, which is 2 1/4. And then we put in negative 1. And so I go 2 to the negative 1 plus 2. Right? I'm just doing this equation right here, and I'm putting those numbers in for x. 2 to the negative 1 is 1 over 2 to the first, which is just that. And 2 plus 1/2 is 2 1/2. Okay, now if it's helpful to you to put this into decimal form, then go ahead and do that. Turn this into 0.25 plus 2, which will give us 2.25. The same thing here. If you want to put this at 0.5, that'd be okay. You're just going to add 2 to that. You're going to have 2.5. Alright? That's fine. No problem with that. Okay, we go on and put another number in for x. We're going to put 0 in for x. So I'm going to go 2 to the 0 plus 2. And everybody knows that 2 to anything power to 0 is 1. So we go 1 plus 2, which is 3. So then I got 3. And I'm going to go ahead and put these points on here. So I got negative 2, 2 1/4. So negative 2, 2 1/4. So a little bit more, just a little bit more. Just like that, right? And then we go to x equal negative 1, 2 1/2. So I go negative 1, 1, 2 1/2. So about right there. Okay, that's a little bit higher than that one, but it's still halfway in between those two. Alright, and then we go to 0, 3. 0, 1, 2, 3. There we go. 1, 2, 3. Ah, no, don't do that. There we go. 1, 2, 3. And then we go ahead and put another number in. We go 2 to the first power plus 2. And 2 to the first power is 2 plus 2 is going to give me 4. So I got 4 now. So I go to 1, 4. And there it goes right there. And we're going to do one more because we're going to put in 2 because I know I need 5 points. So I'm going to go 2 to the 2 power plus 2. And 2 to the 2 power is 4 plus 2, which is going to be 6. So I put 6 in. So I go to 1, 2, 1, 2, 3, 4, 5, 6. There we go. So then we got our line. And now you can see this is going 6, 4, 3, 2 1/2, 2 1/4, 2. It's getting closer and closer, smaller and smaller. It's not getting closer and closer to 0 this time. Now, if you're not sure about that, then go ahead and put in another number. Put in negative 3. So we go 2 to the negative 3 power plus 2. 2 to the negative 3 power is 1 over 2 to the 3 plus 2. And 1 over 2 to the 3 is 1 over 8 plus 2, which is then 2 1/8. And so I got 2 1/8 right there, which is a little bit smaller than 2 1/4. It's not going to get any smaller. It's going to get a little bit smaller, but it's never going to pass 2. So this one, you can tell it's going to be a little bit different than your one before. Let's go ahead and draw a picture. Okay, but it's important that we talk about that ahead of time because we got to make sure that if there's an asymptote, remember one of the special features, this special feature, one of the special features of the exponential is that it has an asymptote. An asymptote is this number that it's getting closer and closer to without ever crossing. Okay, now you may remember for the parent function, the asymptote was at 0. It was right down here at 0. Whoop. But you see, in this equation, I've added 2 to my original function, which means that my asymptote is going to be 2 higher than it used to be. And so my asymptote is going to be right here now. And that makes sense with the data that I have, right? Because the data that I have, it went from 6, 4, 3, 2 1/2, 2 1/4, 2 1/8. And it's just going to keep getting closer and closer to 2, 1/16, 1/32. It's getting smaller and smaller and smaller. You can see that if you put this in decimals too, right? 1/8, that would be 2.0125, I think. No, not 0125, just 125, sorry. I'm just kidding. Okay, and so you can see we're getting closer and closer to 2. So let's go in and let's answer our questions now. So what shape is this? Well, we call this the hockey stick. domain. You see it goes all the way to the left. It keeps on going to the left. And this one goes up. Yeah, it's going up, but it's going up and to the right. And so it's going to go up and to the right forever and ever. Therefore, x is all real numbers. All right, now the range is going to be a little different. This is why it was important that we put the asymptote in first. Because when we look at this, it goes up and up forever, but does it go down and down forever? No, it doesn't. It's going to stop. It's never going to get to this asymptote. The asymptote we said was a -2. And so it's never going to get to -2. And it can't go below it. It can't even get to it. And so what we got to say is we got to say y. Now, is y bigger than that? Oh, so not -2, just positive 2. Is y bigger than 2 or is it less than 2? Well, you can see right there that it's all those numbers, they above the 2. So y going to be above 2. Now, I'm not going to put the little equal sign in. Sorry, this was a little bit sloppy up there. No. Okay, there we go. So x, there we go. Okay, now y, it doesn't have the little line because it can't actually ever get to 2. It just gets closer and closer and closer and closer without ever getting there. X-intercepts, well, is this line ever going to cross the x-axis? No, so we just say none. And that's okay. And the y-intercept, you can see right there, it's 0, 1, 2, 3. So 0, 3. And then we name the parent function, which is exponential. The equation of the parent function is y equals 2 to the x. And then special feature is the asymptote, which has a p in it, even though it's not asymptote. And the asymptote, we need to say where it is. That's the special feature, but where is it? Well, it's right here. You notice that here, that's y equals 2. And so that's the y value that everything's getting closer and closer to. Everything's getting closer and closer to y value. X can keep on going. So what we're going to say is that the asymptote is y equals 2. Now that's not an actual point on my graph. What that is that's the line that it's going to get closer and closer to without ever getting there. Alright, so that's my asymptote. Note that the asymptote was very easy to get by, it should just be this number that's being added on here at the end. Okay? All right, well, that's an exponential for you, and we be done.